they had Jovial running on it.
No, the point was the operating system already designed for the air defense problem, so that it was not a major step to go to timeshare.
The one thing that was done was that Ben Gurley at Information International then designed a PDP-1 interface that they attached to that machine, and Lou Gallinson at SDC designed their end. And this machine sort of handled all of the asynchronous I/O with terminals and everything.
I see.
So in one fell swoop, they got a machine that handled all that aspect that was sort of foreign to the Q32. And what they do with the Q32 is to make the main operating system. And they did a very good job there.
Now that's the Sage machine that is still running in Canada, no?
No. This was the machine that might have replaced. It was an experimental machine, and it never went into production.
It was solid state.
There's a funny story about that machine because there were a few of them built, and it was one of the most powerful machines in the world at the time. And when Licklider first had the idea of a project at MIT, he had in mind that one of those machines would be given to MIT and would be the nucleus of a project. And that was what his first thought was. But as it turned out, that wasn't a very good idea.
And see, that machine had addressing capability more than 32K, didn't it?
It had 24-bit addresses. It had 48-bit words, is what I remember. And there was a plan. We had a plan to try and put a lot of memory on one of them. All these plans always fail. And I remember we worked with an architect. They had this in a room with a high ceiling, and the problem was the memory had to be a certain distance away. So we figured we'd fill the floor with all the memories that could fit near it, and then we'd hang by their claws from the ceiling a bunch more memory units to try and... This was a plan, but it never happened. I have to tell you that throughout history, there have been one plan after another I've been a party of to try and get large memories, and time sharing was sort of one of those. And
I would also to mention that as we were planning Project Mac in the fall, the rest of the fall was winter, 62, and in the spring, 63, there was a kind of an informal committee, and Ed was part of it. He was kind of, I don't know what to refer, a rowing ambassador of McLeiter and other things.
it was an interesting committee. I remember Doug Ross was on it.
Yeah, sure.
So on.
That was the committee that was charged with coming out with a proposal.
Let me jump back to your comment you made about the early SDC, the early BBN, Bolt, Beranek, and Newman machine. You didn't carry on. Now, what was the year of that machine?
Well, let's see, I'm just trying to think. It seems to me the machine was running the first prototype ran in something like 1960, late 60, sometime like that. And then BBN got one. What I did was, having this time sharing in mind, I designed an interrupt system for the PDP-1 called Sequence Break, which I felt was something important for time sharing. And so they built that into that first PDP-1 that was received at BBN. And that project, when we got the funding, then a project was really started with John and Licklider and Shelley Boylan and myself. And then I wasn't there long after it got started.
I thought that you had even left before it got started. But you did the...
His name's on the paper.
I helped write the proposal, and but the actual coding of the time sharing, you're right. The coding of the time sharing, I'd left just before that started.
I think even that you left before Boylan was hired.
No, I knew him.
Well, you weren't that far away, but
well, that may be the case. I don't remember exactly.
Could be. But that machine was beginning to timeshare by summer '62, was my recollection.
Yeah,
that's right.
What was its relation to CTSS?
A rival project?
John was a continuity between
John
the
was
two.
a party to
We
both.
were influenced by John's exposition of the vision, and John was a participant as a consultant at BBN, and he was obviously trying to propagate the vision too.
There must have been some difference in perspective, or
No, I don't think
two
so.
different organizations trying to do the same thing.
The problem was in those days was that nobody had time-sharing equipment, and we were very anxious to demonstrate the idea to as many people as we could get to listen.
I can tell you a major difference, and that's obvious in the name. The object with CTSS was to produce this standard kind of IBM 7049 system and make it available to the user with all the software working in an integrated way and so on. But the BBN experiment was much more modest. It was, let's take this new, fresh, small, fast, inexpensive computer and make it into a multi-user system where you can do experiments and online use and write new programs and so on. And so one was bringing the capability to the sort of existing operating system, computer system, if you like, not operating
computing
system.
center environment.
Right, and the other was, let's try a new experiment.
Well, what I remember as about this, now you can correct me if you think I'm wrong, is that the idea that time sharing could be done on a small machine like the PDP-1 was yours. And that I was skeptical at first, and what I was mainly skeptical about is, which I've been always skeptical about, sometimes wrongly, was whether you could get DEC to make all those modifications, and you did.
While you were out, I was starting to tell that story about how we cornered Ben Gurley in a room in Building 38, and I ran off and got Licklider to get a purchase order number.
Not 38, because it didn't exist then.
26.
26, Building 26, right, pardon me, Building 26, where you had your office. And you ran out and got who? Who was head of RLE then? Was that
Wiesner?
No, it wasn't Wiesner, I think.
No, well, either Wiesner or Zimmerman.
Zimmerman, probably.
No, it could not have been Wiesner
No, I don't
because
remember
Wiesner was in
any
Washington.
about a purchase order.
Yes, I do. And what happened is that was, we
But I don't even understand what the purchase order would have been.
Well, what it was a funny thing in that Gurley, we asked him when was he going to, tell us he would build these drums, the swapping drum. And he said, well, how do I know you're serious? And so the answer is if we can actually get you a purchase order.
Well, but that's what's puzzling me. Namely, the swapping drum was, after all, bought by BBN, not by MIT.
No, we each bought one. We ordered them the same day together.
Oh, really?
Jack Dennis
Absolutely.
ordered.
They were ordered the
well
same
then,
day together.
I'm pretty
two
sure
drums
I
were
wasn't
ordered.
involved.
You were.
Unfortunately, I think that the point
other
that,
witness has passed
Anything
away.
having to do with money, I have a tendency to forget.
I think that the important thing that Ed brought up, and I want to reemphasize, the CTSS was developed in an environment in which there was a single machine that was serving the whole of MIT. So any work had to be done within the context of serving the whole of MIT, both in terms of developing by stealing time, and also that the system that came out must be, as the name indicates, compatible with the established use of computer. That was kind of tricky.
Yeah, in fact,
Right. In fact, I don't believe it would have succeeded, in the sense that if Project Mac had not been able to buy another machine,
well, the
then
key,
we would never have been able to steal enough time to
wasn't-
make practical time sharing in that machine.
it wasn't genuinely compatible until we could, or at least reasonable, until we had that second bank of memory.
Yeah.
So that, in fact, the ordinary user didn't have to change his programs. And in fact, the summer study of Mac was run using the computation center machine.
Yeah.
And in fact, we
Which
did
summer study?
the famous 63.
63.
Yeah,
There was another one in 64, right?
No,
it was 63.
It was 63.
Uh-huh.
Well, we may have run
They
a
do.
second one in 64, but the big
No,
one, the
why
initial
not?
send-off
We
one.
didn't run one in 64 as a summer study. It may have been guessed.
Okay, fine.
But it was
But
not
63 was the big one.
Yeah.
And we used that because the Mac duplicate didn't show up till fall.
Yeah.
We were using the borrowing the time off.
Yeah.
And Ed's quite right. That machine was badly overloaded.
Yeah,
So
and-
it was a squeak to get it all through the same
Yeah,
system.
but I must emphasize that part of the motivation for Project Mac was really make CTSS available full time to the community, while the computation center machine, I don't remember what the schedule was, but there were certain times during the day on certain days in which was available in time sharing mode.
Well, I think that,
but
yeah.
it was limited.
but Ed reminded me that the choice of the word or the name compatible time sharing system, I don't consider to be such a great one. In fact, it was a local battle of the moment, and and in fact, it even led to a joke system of the incompatible time sharing system, which was developed on the PDP-6 later.
And so did Multics that led to Unix.
CTSS got abbreviated to its initials pretty quickly, and that saved the day.
This one point that John made about his not thinking time sharing would work on a small computer. I can't emphasize enough this notion that I feel I had an idea, which was to take the small computer and make it pretend it was doing what McCarthy described to me as time sharing. In that I knew it wasn't the right idea or wasn't done properly, but the concept was that by making it work and showing it to people, we would get their enthusiasm for doing it right. And this problem of getting the manufacturer to make all of the changes was a very hard one. I know that, for instance, even when the PDP-6 came out, I recall that I asked John and senior people at Digital Equipment, Ken Olson and Harlan Anderson, and I think Gordon Bell, to have a lunch in Maynard to try and convince them to make the changes to the PDP-6 that would make it good for time sharing. And John knew what these changes should be, and so did I. They were basically, memory protection and some kind of relocation scheme and so on, and just a few changes. At the end of the luncheon, I think it was Harlan Anderson who summarized Digital's position. Well, that was very interesting, and they might consider it on the next machine they make, but they weren't interested in doing it this time around. And it turned out that I think time sharing was a major factor in the sale of almost all their early machines.
Yeah.
Well, but by the time they actually came out with it, they did put those things in.
Sure.
Yeah,
They changed their
did,
tune pretty quickly.
Now, maybe the PDP-3, are you thinking about?
No, this was the PDP-6.
Six,
No, the 6 initially was thought of as a big batch machine.
Yeah.
But they rapidly switched their position.
Well, the proposal to Project Mac was based on the PDP-6.
And in fact,
And let me also mention a point. It's a small time sharing system. I don't know personally what happened at BBN, but I know that had a profound effect at MIT, that is the time sharing system that Jack Dennis developed, had a profound effect in two respects. One, that it allowed a lot more students to play around with the PDP-1 because it was actually used. Second was where Jack began to develop a lot of ideas that had to do with segmentation and so forth that came to fruition. So it was an experimental environment of considerable importance, both for students and for Jack.
Let's get that in the chronology. How does that fit in with the other two, or with CTSS and?
Well, I think that Jack's effort was slightly behind the BBN effort.
well, he also had a different design perspective.
Yeah.
And in particular, Jack was trying to make each user of the PDP-1 see a virtual PDP-1. So
I think that was the BBN concept too.
well, he wanted to do it in hardware. So he kept messing around with the machine in order to make the machine do the multiplexing. And he didn't really try to do it in the software operating system.
He did a lot of hardware modification himself. He did the design, and what was the name of the technician that was there?
Mackenzie.
Mackenzie did a lot of
He still works out at that.
of the work.
I have to tell a little story about this era. The PDP-1 was brought in, I guess, into Building 26.
Yeah.
And the next room was the TX0, which we mentioned earlier, an experimental machine done at Lincoln Labs. And one day these two machines were connected together. And you're I'm going to tell this little story about Mike. I think it was Mike Levin invited you down to show you a chess machine program that they'd written for the PDP-1. And as I understand, what happened is McCarthy came to the PDP-1 and started playing this chess machine, and it was playing good chess, but he noticed that when it typed, it would hesitate between the letters, which was very unusual for a computer as it typed. And what did you do? Did you rush to look in the other room or something?
Yeah.
And in the other room, there was Claude Shannon, who'd been told the same story, that there was a chess machine on the TX0. And in fact, all that had happened is they'd connected the two typewriters together, and John was playing Claude Shannon, and and each thought they were playing a computer. With a little bit more work, they could have done a better job of just buffering the input. And
Yes,
typing it
right.
out, right?
Actually, that machine was a very rich environment. The I thought it was a PDP-1. The Space Wars got initially done.
Yes.
And
The real birth of the video games can be traced to one person, Steve Russell, who had this concept in mind. But it's funny how you have different recollections. I was having a party at my house, and I remember Steve Russell was there, and he said, "I have this idea. I'm going to make a program of it." And he described Space War, and he went and did it, and it was an immediate success. Now, we had various games running on the PDP-1 at BBN, and I remember several people at different times would come and say, why are you wasting your time? You hear you have a computer that costs $200,000 and it's used to play a game. This is ridiculous, But a lot of us knew, some didn't care about the cost, but some of us knew that the cost was going to come down, and eventually game playing on computers would be a big thing.
Not only that, I remember having to buffer when I was director of Project Mac some of that work from the Department of Defense and so forth. Mm-hmm. That is, a lot of us recognize that a game is just an example of doing certain thing, and what was important was not the game, but the technology that was developed in the process of making a game. Another thing that I remember distinctly is the beginning of putting terminal in the homes of people. That is a decision that I had to make, and it was very clear to me of the tremendous advantage of allowing people and paying for the private line, because it had to be a private line, and to go to the home of people. And the obvious advantage is that people were working a heck of a lot harder as a result. But the second that was subtle, and I can quote specific example, putting a terminal at home for some people saved their marriage. Because those were people that were so dedicated that if they couldn't have worked at home, they would have been in the office, and there was considerable tension. I don't remember the name of the person. There was one in your group. Definitely there was that issue that came up.
Now, in my case, I consider myself perhaps the first person who had to send his terminal back.
Yeah.
And what happened is I had a Model 35 teletype.
God.
And things didn't work quite perfectly. And this was the only Model 35 that the Natick telephone company had ever seen. It had to be installed by your local telephone. I was away on a trip, and at 2 a.m., the computer decided to call my teletype for some reason. So it started ringing its bell and typing, and this woke my wife up. And, she tried, I had shown her how you type something to make it stop, but it didn't work. So she tried calling MIT, and she couldn't find anybody. She calls the telephone company, and some sleepy person says, well, try this, that, and that didn't work. And so they said, pull the cord and, just pull the AC power cord. So she went and pulled the AC power cord. Well, it turned out that wasn't a small thing because they had it screwed in, so she had to unscrew this. So she's not mechanically minded. So she did that, and the thing sat there quiet for a while, and then the computer tried to call it again. Well, to let you know that a computer is calling your teletype and you're not plugged in, it has a very, very loud telephone bell. So this bell started to ring. So she was ready to take an axe to it or something. Wow. She called him up again. They said, well, you'll find a little small wire that goes somewhere. Find where it goes and unscrew it and unscrew every wire, Well, finally, she got the thing quiet.
The story about the telephone company and the terminals, there are lots of them. Let's realize that this was a time, 63, in which if you call the telephone company and said, I want a Model 35 installed to talk with a computer, then the answer would be, it's never been done before. It's impossible.
Well,
And in
they
fact,
said more than that. When we wanted to connect the computer to the Twix network, they said it's forbidden by our tariffs. It cannot be. You cannot do it.
Sure.
They
And
invented this Twix
eventually,
Prime.
What?
They
Well,
invented this Twix
but
Prime.
the way even
Right,
Twix
that's right.
Prime came about was in the beginning everything was forbidden.
Yeah.
And then I remember one day we heard that it wasn't forbidden, and I called a senior person at Bell and I said, I understand that's not forbidden by your tariffs and anymore, and they said yes, that's right. And I said, well, what was changed? And after a long pause, he said, our interpretation of the tariffs.
that's right.
Yeah, right.
Well, the fact of the matter was that there was a fellow who was pretty high in long lines. What was his name already?
It slipped
met
my
him,
mind.
at AT&T, who really got interested and saw the point. So he started managing things inside the Bell, so that all this thing became possible, and eventually they had the Twix Prime, which was an inverted frequency system, so that you could use it with computer without having the problem of people by mistake calling a computer and having trouble. That was the.
But it was let me just say that it was a very infuriating.
Oh yeah.
It was an infuriating period because, to some extent, the Bell system people were very patronizing. They had a timetable of their own. They thought they'd bring it in a decade or so. And they viewed any transformation of using data over the analog telephone lines as being kind of an anomaly that they would tolerate only in small amounts.
Well,
and the modems were these tremendously cumbersome boxes that, which today you can get in a fist-sized box.
You get in a chip now.
But there was a lot of persuading, and the character set. I remember you were too, when we went to visit Teletype.
But they were just plain
in Texas, in which, well, of course, they had made a customer survey, and of course, all the customers said, since they never used lowercase, that they were not interested in lowercase. They didn't know what to do with it. It was a very frustrating thing. But then it got to the stage in which we established good relation with the local New England Tel. And when I went around, as I was doing a lot, giving talks and demonstration of CTSS all over the place, I would tell them, have your local telephone people call so and so in New England Tel, and we'll tell you exactly what to do. And that worked beautifully. Except one time that I gave a talk in this area, and they gave me something with him. The character set was completely screwed up. So I was sitting there giving the demonstration, and the character were printing were all wrong. I don't know how I managed.
One major thing, that part of time sharing was to get the computer to work. But there was another part, which was to have a low-cost terminal for someone to use. And